Welcome to this video. So today we are going to be looking at questions from the mid-semester exam for Medical Mathematics 2. Okay, so this exam paper has three sections. There's section A, which is multiple choice. There's section B for short answers, and then there's section C for long answers. So we're going to answer all the sections in this paper. Okay, so let's start from section A. Okay, let's start. I was saying let's start from section A. Okay, so we start from the first question there. So the first question they are saying convert 225 degrees to radians. Okay, so here we're just using the formula. The angle in radians is equals to the angle in degrees multiplied by pi divided by 180. Okay, so here I'm going to say the angle in radians is equals to the one in degrees has been given as 225. Okay, then multiplied by pi divided by 180. Okay, so what number can go into 225 and 180? So 225 divided by 45, okay, it gives me 5 pi on top. And then if I do 180 divided by 45, I get 4. Okay, so this is the answer here. I'll just go here and pick C, okay, because that's 5 pi over 4. Question 2, they're saying the blood glucose level of a patient measured in millimoles per liter throughout the day is modeled by this equation here. Okay, so the equation is G of T, in case you're not able to see it, 3 cos, and then 2T, okay, minus pi over 6, and then 7. Okay, so they're saying where T represents the time in hours after midnight. And then the question is state respectively the amplitude, the period, the phase shift, and the vertical shift. Okay, so the amplitude is just the modulus of the coefficient of the trig ratio that you have. So it will be 3 here because that's the coefficient of this cos. Okay, so it will just be 3. The period, okay, is equals to 2 pi divided by the coefficient of t, which is 2. So it will just be 2. And then the phase shift, okay, you equate whatever you have in the brackets here, you equate it to 0 and then you solve for t. So that will be t minus pi over 6, okay, is equals to 0. So meaning that this will just be 2 is equals to pi over 6. So I just want to have t on my left-hand side. So I'm going to divide by 2. Even here, I'm going to divide by 2. But dividing by 2 is the same as multiplying by half. So it means my t will just be equals to pi over what? 12. Okay, and then the other thing was my vertical shift. Okay, so my vertical shift is just the number that is being added there. The minus, the plus 7. So plus 7, that's the vertical shift. So you go now on the options and check which one matches whatever you found. So the amplitude is 3, okay? So here I should have said pi, okay? Because the 2 and the 2 are the one that are canceling. So this is pi. So the period is pi, okay? The phase shift is pi over 12. So the pi over 12, I can see it on A there. And then the vertical shift is plus 7. So I'm going to pick A as my best answer. Question 3, they're saying y is equals to e to the power 2x sine x, and then they want us to find dy dx. Okay, so we notice that this equation here is a product of two equations that are in terms of x. Okay, so this one here can be u, then this one here can be v. So we're going to find the dy dx using the product rule. So the product rule says that we differentiate u, then we multiply by v, and then we say plus, differentiate v, and then we multiply by u. Okay, so my u is this guy. So this guy is e to the power 2x. So if I differentiate this, what do I get? Okay, so if I differentiate e to the power something, I just have to differentiate whatever I have in the power. Okay, so I get 2, and then I multiply it by the same function e to the power 2x. okay, and then multiply by the v function, which is sine x. And then I say plus. Now I have to differentiate the v. So the derivative of sine, the derivative of sine is cos x. And then I'm multiplying this by the function, which is u, 2 to the power 2x. Okay, so that will just be, I factorize the e to the power 2x, this one. So if I factorize the e to the power 2x, I remain with 2 sine x plus cos x. Okay, so you check on your options if you have such an answer. We see that it is on A. So here we would have picked A as the correct answer. Okay, what about this one? They're saying a biomedical researcher is studying plasma cortisol concentrations measured in nanomoles per liter in patients undergoing treatment for adrenal insufficiency. For easy analysis, she decides to code the cortisol values by standardizing them using this transformation here, where X, okay, that X there, is the original plasma cortisol level and Z is the coded value. During the analysis, the mean and the standard deviation of the coded cortisol levels are observed to be 8.3 and 2.5 respectively. Determine the mean and the standard deviation of the original plasma cortisol concentrations. Okay, so this is the mean of the coded cortisol, which is this Z. And this one is the standard deviation for this coded cortisol, which is Z. So I'm going to say expected value of Z is actually equals to 80.3. And then the standard deviation, okay, of Z is equals to 2.5. Okay, is equals to 2.5. So from the standard deviation of Z, I can write SZ. I can actually find the variance of Z. So the variance of Z will just be the square of the standard deviation. So 2.5 squared, I'll get 6.25. Okay, so now I want to find the original mean and the original standard deviation. Okay, so on this equation here, I'm going to make X the subject. So yeah, I have Z is equals to X minus 43 over 25 over 1. So I'm going to cross multiply so that I have X minus 43 is equals to, okay, 25Z. Okay, so it will be X is equals to 43 plus 25Z. Okay, so this here is X being represented in terms of ZZ. So I'm just going to say the expected value of X, which is the original mean, is equals to, I take the expected value of whatever I have here. So I can even start by writing 25Z plus 43. So that will just be equals to, okay, if I distribute this expected value to the 25Z, I get 25 expected value of Z, and then plus the expected value of 43. But 43 is a constant, so the expected value of a constant is always a constant. Okay, so this is what I have. So it means the expected value of XC will just be 25, and then the expected value of Z has been given as 80.3, and then plus 43. So we can punch this onto the calculator. So it will be 25 multiplied by 8.3 and then plus 43. So that gives me 250.5 nanomoles per liter. So this is the expected value. Okay, that's the expected value. We can now try to find the standard deviation. But for us to find the standard deviation, we need to use the formula for the variance. So I'm going to say variance of X is equals to variance of 25Z plus 43. Okay, I'm using this equation here. So now for the variance, we know that when you distribute the variance to the 25Z, okay, if I factorize the constant from the variance, it's going to be 25 squared like this. Okay, and then I have the variance of Z, and then plus the variance of the constant. So now the variance of the constant is 0. Okay, the variance of the constant is 0. So this part here is 0. So I want to remain with the 25 squared, and then the variance of z, which is 2.25. Okay, so let's do 25 squared multiplied by 6.25. So if I do that, I get 3,906.25. So meaning that my standard deviation of x will just be the root of this same number here. Okay, so root of that gives me 62.5 nanomoles per liter. So I just now go to check which one has this standard deviation and this mean. So I see that it's B, this one here. So I pick it as my answer. Okay, we'll move to question 5. Question 5, they're saying the rate at which a drug is absorbed into the bloodstream at time t hours is modeled by this equation here, where AT represents the amount of drug absorbed in milligrams after t hours. Given that the initial amount of drug absorbed, okay, the initial amount of the drug absorbed is just 0 milligrams, which of the following represents AT? So to find AT, we just have to integrate its derivative. So I'm going to say the integral, okay, of t squared, then e to the power t to the power 3 like this. Okay, and then we're integrating with respect to t. Okay, and then from there, I'm going to say let my u be equals to t to the power 2. Okay, and then my du be equals to e to the power t to the power 3 like that. Okay, so this is my dv. So my dv is equals to this. Okay, so from here, I'm going to say my du is equals to 2t dt. Okay, and then here I'm integrating both sides. Okay, so if I integrate this side, I get v. Then if I integrate this side, okay, what am I going to get? Okay, if I integrate this side, I'm going to differentiate first of all the power, and then divide this same function by the derivative of this power here. So it would be 3t. Okay, so that's what we have there. Okay, so wait a minute. So I was trying to use this method for by parts. Okay, but I think this method won't work here. Okay, so let's use another method. Let's try to use substitution, because by parts it's looking like it won't work here. Okay, so let's try by substitution. So by substitution, let's say let u be equals to t to the power 3. So du will just be equals to, if I differentiate this with respect to t, it will be 3t squared dt. So let's make dt the subject. So if I make dt the subject, then I'll divide by 3t squared, even here 3t squared. So I have dt is equals to du over 3t squared. Yeah, I'm sure this one works better than the by parts. So this will be the integral of t squared multiplied by e. Okay, this t to the power 3 has been put as u, and then multiplied by dt is du over 3t squared. Okay, yeah, so this one will work. So here it means t to the power 2 will cancel, t to the power 2 will cancel. So I want to remain with what? I want to remain with the u, supposed to be e to the power u over 3 and then du. So the 1 over 3, I take it outside. So it's just the integral of e to the power u du. So this will just be 1 over 3. The integral of e to power u is just e power u and then plus c. So this plus c there is a constant of integration. Okay, so that is my a of t. So now remember the initial concentration that we are given. We were told that a of 0 is actually 0. So if I say A of 0 is actually 0 milligrams. So it will be A of 0 is equals to 0, which is equals to wherever there is t here, I have to put 0. So now remember we had said u was t to the power 3, right? So where there's u there, I'm going to say 1 over 3, and then e, where there's u there, I put back my t, but my t now is 0. Okay? So it will just be 0 to the power 3 and then plus c. So meaning that I just have 0 is equals to 1 over 3, because this will just be e to the power 0, which is 1, and then plus c. So this simply means c will be equals to minus 1 over 3. Okay, so it means my a of t will be equals to 1 over 3 e to the power t to the power 3, okay? And then minus 1 over 3, because this is my c here. So I check for where I have such an answer. It is on part what? B. So I pick it as my answer. Okay, and then we go to question 6. So question 6, they're saying the curve, okay, passes through the point 4, is it 3, 4? 3, 4. Find dy dx. So dy dx, I'm going to multiply throughout here by dy dx. Okay, so this is implicit differentiation. So if I differentiate this with respect to x, I just get 2x plus differentiate this y with respect to x. Okay, so yeah, I differentiate in the normal way. So I get 2y, but because it's y, then I have to multiply by the dy dx. Okay, is equals to the derivative of 25 is 0. So now they're saying at this point, so wherever there's x, I put 3 plus 2, where there's y, I put 4 dy dx is equals to 0. So this would be 6 plus 8 dy dx is equals to 0. Okay, so meaning that the 6 goes to the other side, so I have 8 dy dx is equals to minus 6. So dy dx is equals to minus 6 over 8, which will just be minus 3 over 4. Okay, so I'm going to pick A as my best answer there. Okay. We go to another question, which is question 7. Question 7, they're saying a ventilator, okay, a ventilator pressure model, P of theta is equals to 8 sine theta. An alarm triggers when P is equals to 4. For theta, which is between 0 and 2 pi, which set gives all the solutions of 8 sine theta equals to 4. So 8 sine theta is equals to 4. We're just finding this theta. So I divide both sides by 8. I get 4 over 8. So this is sine theta is equals to, here this is the same as half. So theta is equals to sine inverse of 1 over 2. So sine inverse of 1 over 2, this is a special angle. Okay, it's just pi over 6, the same as the 30 degrees. So on that diagram for the quadrants, it's all students take Coke. So sine is positive here and here. So this angle that we found there is here. We also need to find the angle here. So the angle here, okay, if you're using degrees, it's 180 minus the angle that you found in the first quadrant. Okay, if you're using radians, it's pi minus the angle that you find here. So the angle that I found here is pi over 6. So I have to find the angle there. So I'm going to say angle in the second quadrant will just be equals to pi minus pi over 6. Okay, so here to be 6 and then 1, so it will be 6 pi minus pi, which will just be equals to 5 pi over 6. Okay, so 5 pi over 6 the same as 150. Okay, so the set will just be from pi over 6 to 5 pi over 6, which is what we can see on A. So we choose A as our best answer for this problem. Okay, what about question 8? Question 8, they're saying an emergency unit receives on average lambda is equals to 2 severe allergic reactions per night. Assuming a Poisson model, what is the probability of exactly 3 such cases tonight? Okay, so we know that if a random variable x follows a Poisson, okay, then the PMF is equals to x is equals to k will be e to the power minus lambda, and then lambda to the power k over k factorial. So this will be, okay, since they have said the probability that x is exactly 3, okay, but the lambda has been given as 2. So this is e to the power minus 2 multiplied by 2 to the power 3 over 3 factorial. So you can pass that into the calculator. Okay, so I have e to the power minus 2 multiplied by 2 to the power 3 divided by 3 factorial. So my calculator says 0.180447044. So just round it off to 3 significant figures. It will be 0.180 like this. So we come here and choose the C as our best answer. I go to question 9. Okay, question 9, we're finding the volume of revolution. So they're saying the curve C given by this equation here, okay, encloses a region R with linear curves. X is equals to minus 2, this line here, this one here, that's the x is equals to minus 2, and then x is equals to 2 is this line here, and the x-axis, which is this part here, okay, and then this is the curve here. Okay, so that is the area there in between, okay, shown in the diagram. So the area R, okay, the region R is rotated 2 pi radians around the x-axis. So this thing here is being rotated around the x-axis like that. Okay, so it forms a solid of revolution. Find the exact value of this volume. So the volume, okay, of revolution rotated 2 pi radians around the x-axis is given by pi, and then the integral from the lowest point of x to the highest point of x, so minus 2 to 2, okay, of y squared dx. But what is y squared? It's just this guy here, and then I square it. Okay, so I'm going to say 1 over 5 plus 2x, and then squared dx. So how can you integrate this? We use the substitution. Okay, so I'm going to say let u be equals to 5 plus 2x. Okay, let u be equals to 5 plus 2x. So it means du will just be equals to 2 dx. So let's make dx the subject. So dx will be equals to du over 2. Okay, so now if I change the variable of integration, it means these limits will change. So what I have is pi, and then the limits will be from u1 to u2, okay, which are the new limits. And then here I just have 1 over u squared is not is equals to, but dx. So the dx is this du over 2. Okay, from here, the 1 over u is the same as u to the power minus 1. So I have pi, and then u1, u2, u to the power minus 1 multiplied by these 2. So it will be minus 2 multiplied by du d2. Okay, and then from there, what do I do? I'm going to say volume is equals to pi. Okay, and then these 2, I bring it in front here. So it will be pi over 2 here. And then the integral from u1 to u2 of this u to the power minus 2 du. So I can easily integrate this. So if I integrate this, I add 1 to the power and then divide by the same power. So it will be u to the power minus 1 over minus 1. Okay? And then the limits are u1, u2. Okay, so simply meaning that we are just having pi over 2. Then inside there, it will just be minus 1 over u. Okay? And then I have u2, u1. So I can put back my u. So what is my u? So this is pi over 2, okay, minus 1 over my u was 5 plus 2x. Okay, so once I bring back my x here, it means I can bring back the original limits that I had, which was from minus 2 to 2. So that was minus 2 to 2. And then I just substitute them. So I have pi over 2 and then minus 1 over 5 plus, so this here will be 2 multiplied by this 2. So that will be 4. And then I say minus, okay, minus 1 over 5, okay. And then here it will be 2 multiplied by this minus 2 when I substitute. So it will be minus 4 like this. Okay, so from there, what do I have? I have that my volume is equals to pi over 2. And then inside there, okay, I have minus 1 over 9. Okay, and then inside here, there, I have minus 1 over 5 minus 4, which will just be minus 1 over 1. Okay, so this is just simply minus 1 multiplied by this negative outside. I have a plus 1 like this. Okay, so to be equals to pi over 2, and then what we have inside there is just 1 minus 1 over 9. So this is the same as 9 over 9. So it will be 9 minus 1. So this will be 8 over 9. So I'll write 8 here over 9. Okay, and this will be equals to, I cancel the 2 there, 1, cancel the 2 there, 4. So it will be 4 pi over 9 units cubed, or cubed units. So we look at the answers, we see that the answer is just C there. Okay, let's look at question 10, which is the last question, section A. So here they've said sine x is equals to 3 over 5. Okay, where x is an acute angle, that is, it occurs in the first quadrant. So now, by SOHCAHTOA, remember, okay, sine is just opposite over adjacent, cos is adjacent over, sine is opposite over hypotenuse, and then cos is adjacent over hypotenuse, tan is opposite over adjacent. So if I was to draw a triangle here, okay, the x would be there. This is 90 degrees. So the opposite is this guy. This is the hypotenuse here. This is the opposite. This is the adjacent. Okay, so sine is equals to opposite over adjacent. So this 3 here is the opposite. Okay, the hypotenuse is 5. So by Pythagoras theorem, we can find this adjacent. So it will just be 5 squared is equals to 3 squared plus a squared, meaning 5 squared minus 3 squared is equals to a squared, meaning 25 minus 9 is equals to a squared, which will mean 16 is equals to a squared, and 4 is equals to a. So the adjacent is just 4. Okay, so from there, I can actually find my other trig ratios like cos x. So cos x, this is the angle. I'm getting adjacent over hypotenuse. Adjacent is 4 over hypotenuse 5. Okay, so now they're saying find the value of 2x. So now remember the double angle formula. This is the same as sine A cos B plus sine B cos A. Okay, so now when I am given 2x there inside, that's the same as the x plus x. This will give me 2x. So now by this double angle formula, that's just sine x cos x plus sine x again cos x again. So these two here are the same. So it will just be 2 sine x cos x. So this will be equals to sine of 2x, okay, 2, and then sine x is what? Sine x is 3 over 5, cos x is 4 over 5. So let's multiply. 2 multiplied by 3, I get 6. 6 multiplied by 4, I get 24. 5 multiplied by 5 multiplied by 1, I get 25. So that's the answer there, 24 over 25, which is on A. Okay, which is on A. So we're done with section A. So thank you so much for actually watching this video. Okay, if you'd like to access the other videos for the other part, like section B, these videos here, okay, you are free to actually register with us. You're going to find the videos on our website. You can use them to learn anytime, anywhere. Okay, we also have videos for the tests, for the quizzes, and for all the tutor sheets. So as you're preparing for your exam, you can benefit from our platform. Okay, you can actually benefit a lot from our platform. Okay, so if you would like to register, you can check the link in the description below here. Okay, you're going to find 3 links. 1 is for the website. 2 is for the mobile app. So on the mobile app, you can actually even download our videos and watch them offline in your blankets. Okay, so you don't always have to use data when you're using our platforms. And then 3, you'll find a link for the registration guide. Okay, so it's going to tell you how you can register, how you can make an account and register for your desired course. Okay, so if you come on our website, you see something like this. So you can register for this course math or any other course that you want. So if you open the course math, you'll find 2 folders. You go in general mathematics. Okay, so if you want the past papers, you come here. If you want the tutorial sheets, you come here. So here I'm going to show you the tutorial sheets. Okay, so the tutorial sheets, you go to Unilus folder. Okay, so you just wait for it to load. Okay, so you find first semester, second semester. So depending on which semester you are, we have videos for both semesters. So I'll go in second semester for this video. Then once I'm here, I go to video solutions. Okay, so video solutions, you can see we have the assignments there. We have tutorial sheet 1, tutorial sheet 2, 3, 4, all the way up to tutorial sheet 7. So you can watch these videos at your own time, at your own pace, as you are preparing for the what? For the exam. Okay, so those are the tutorial sheets. And if you want, you can actually go to the folder for the past papers here and access full videos for the quiz, for the tests, and for the mid-semester exam. Okay, so thank you so much for watching. This has been Tutor Poul Solutions. Okay, until next time.